Hello, scientists. We are going to do the second part of Lab 9.03. In part one of the video, we did parts 1, 2, 3, 4, and 5. Now we're going to start on part 6, looking at resistors. And we're still going to use the same simulation that we did in part 1. Right now, we're going to use that circuit construction kit simulation to build the circuit below. We're going to put in a battery, as we see right here, and we're going to put in a resistor. This up and down squiggly line here stands for a resistor. And then we're going to measure, as we vary the battery voltage, we're going to measure the current into the battery. So let's go do that. So we are, again, here in the simulation, and we're going to use a battery, which we're going to vary the voltage of, connected to a resistor, and then we'll measure the current at the battery as we use various different voltages on the battery. So here's our resistor. Let's see the value on the resistor. It's 10 ohms. To start out with the battery, let's change the voltage, and let's go up by 3s here. So let's start at 3 volts, hit play, make sure we have an ammeter here. Oops, let's do the non-contact ammeter. It's a little bit faster. So let's hit play here, and we see that we're currently working with about 30 amps. So we have 3 volts here and 0.3 amps here. I apologize, it's not 30, it's 0.3 amps. So let's change the voltage. Let's go up to 6. We'll keep the resistance the same. And now we've gone up to 0.6 amps. Let's change the voltage again. Let's go up by 3 again, so we go to 9. Oops, that's not what we wanted. We wanted 9, not 96. So we see it's 0.9. When this is 9 volts, this is 0.9 amps. Let's go up by 3 again. Let's go to 12. And we see 1.2 amps. All right, let's change this to 15. Let's play. All right, we have 1.5 amps, 15 volts, 1.5 amps with 10 ohms of resistance. Let's change the voltage one more time. Let's go to 18 volts, going up by 3 again, and we see we have 1.8 amps. Now you have all the data to fill out Table 5. Hopefully you've already filled it out. Now we need to explain what might be happening to cause the change in current. Well, we kept increasing the battery voltage. Do you think that had a relationship to the current? You might want to run a quick graph if you have a graphing calculator or a graphing calculator feature on your computer and figure out what the shape of the graph is here between if you grab battery voltage and the current into the battery, this as the independent variable and this is the dependent variable on the y-axis. What is the shape of the line on that graph? So on to part 7. We're going to observe voltage and current relationships for variable resistors. We're going to build a circuit below, and again we're just going to put in a battery and a resistor. We're going to measure the voltage across the resistor and the amps next to the battery, or the current next to the battery. We're going to vary the value of the resistor at least 10 times and record that in the data table. We're going to record resistance, current, and voltage for each trial. So we're basically going to build a simple series circuit here. We're going to measure the current and the voltage as the resistor varies. So it's your job to fill out table 6 while I show you how to build that circuit. Basically, the circuit is the same as it was last time. I'm just going to change the voltage here back to 9, which is kind of the standard voltage we use in this simulation. I'll take away this ammeter for the moment. I will put the voltmeter. Oh, here's my voltmeter on the battery here. Let's start out with a resistance of 5 and work our way up by 5s. So let's hit play here. So the battery has 8.99 volts. It's a 9 volt. We set it, oh, sorry. The resistor has 8.99 volts. The battery has 9. Let's take the current here. It's 1.8. So with a 5 ohm resistor and a 9 volt battery, we have a current of 1.8. There are the numbers for your first table, for the first entry in the table. So let's change the resistance now. Let's go to 10. So you can put that in the table under the second row. We see the current goes down to 0.9 and the battery is still the same. Let's change the resistance to 15. We've gone down to 0.6 amps and we're still at 9 volts. You can see the stripes on the resistors changing when I change the resistance. Stripes on the resistors is a code indicating how much resistance is in a resistor. If you open up some kind of electronic device that has resistors on a circuit board, you can see that they will have colors much like this, and you can use a decoder to figure out how much resistance. So when we up this, right now we're at 20 ohms in this resistor. Our current is 0.45 amps. Let's go up to 25. So at 25 ohms, our current goes down to 0.36 amps, and we're still at 9 volts. Let's go to 30. At 30 ohms of resistance, we get 0.3 amps, and we still have 9 volts. At 35 ohms, we go down to 0.26 amps. So the more resistance, the fewer amps are getting through. We're still at 9 volts. Let's change resistance one more time. Let's go to 40. I bet you can make a prediction. Oh, the amps goes down again. The current, the number of amps, the current flowing through the circle, you can see these blue electrons, they're slowing down. Let's go to 45. And as we predicted, it continues to go down. The current continues to decrease. And at our last point here at 50 ohms, we're at 0.18 amps and we're still at 9 volts. So now you have all the information you need to fill out to fill out table 6. what we want to do now is determine the algebraic relationship for resistance and current. Is it a linear relationship? Is it exponential? You kind of figure it out. See if you can make a graph in Excel. Use the information here to look at resistance and current. So resistance here and current here. Plot these two either in Excel or Google Graph or on your graphing calculator and see what the line looks like. Is it straight? Is it curved? And then do the same for resistance and voltage. What's going on there? Explain the relationships in terms of what you think is happening in the circuit. What's happening with the electrons? What's happening with the speed of electrons, the amount of electrons getting through? Include how this experiment is like the one where you added light bulbs. Remember the series circuit where we kept adding more light bulbs? And light bulbs, you can see that are squiggle, which means they're basically a resistor. They resist the flow of electricity and turn some of that electrical energy into light energy. So you can draw some parallels between part 4 and part 7 for question 32. So let's move on to part 8. Resistors in a series circuit. We're going to add some more resistors just like we did with light bulbs. We're going to construct a circuit figure in the circuit in figure 1. So basically line up 3 resistors and connect them to a battery. Make the resistors have different values and record the value of each resistor. So here in our table 7, as we vary the voltage or the ohms of each resistor, we're going to record that here. We're also going to record the voltage at each resistor, as you can see in the diagram here, and we're going to record the current at each resistor as well as the total current and the total voltage across the battery. We'll calculate R using Ohm's law, V equals IR, for the total resistance in the last column. All right, let's go get some data. So we have to line up 3 resistors, all with different values, and we're going to measure the voltage and current at each resistor as well as the total voltage and total current. Okay, so I've set up a series circuit here with 3 resistors, and I'm going to set each resistor to be a different value. Let's set the first one to be 5 ohms. Let's keep the second one at 10. And I'm just right-clicking here to change the resistance again. And the last one's 15. So write those down in your table. Now we need to measure the voltage at each resistor and the current at each resistor. So let's measure the voltage at this one. So the voltage at resistor 1, which is 5 ohms, is 1.5 volts. The voltage at the second resistor, which is 10 ohms, is 3 volts. And the voltage at the third resistor, which we set to 15 ohms of resistance, is now 4.5 volts. The total volts is 9, because it's a 9-volt battery. So now we've measured the voltage. Now let's measure the current. The current at resistor 1 is 0.3. The current at resistor 2 is 0.3. And the current at resistor 3 is 0.3. The total current is 0.3 amps as well. So there you have the data to fill out part 8. So you have all of the information you need for table 7, and you need to decide how is the total resistance related to the individual resistances. And you can find the total resistance by taking the total voltage and dividing it by the total current. You also want to find out how the total current is related to the individual elements. Well, and you've already found that out. Just look at the table and do some analysis. So I'll let you finish question 34. Question 35 says, how is the total voltage related to the individual voltages? Again, look back to your table and do some thinking. The total voltage, look at the total voltage and look at the voltage at each resistor. Now you need to write a paragraph explaining what you think is happening in the series circuit to cause the above relationships. You may want to draw some conclusions with the light bulbs, or draw some parallels to the series circuit you did with 3 light bulbs. Light bulbs are just resistors that glow, remember. All right, I will let you write that paragraph on your own. Make sure you explain what's going on with the electrons. Are there more electrons? Are there less electrons? What's happening because of those resistors? What's happening to the speed of the electrons? You can see those electrons flowing in the simulation. So that gives you a good idea of what's going on. All right, part 9, we need to look at resistors in parallel now. We're going to build a parallel circuit with 3 resistors in a parallel circuit. We're going to measure the voltage across each resistor, and again we're going to measure the amps at each resistor as well, and the total amps and the total voltage, and record it all here in table 8. So you can record while I measure. Okay, I've built a parallel circuit here, and I've used the same resistors. So resistor 1 is 5, resistor 2 is 10, and resistor 3 is 15. So 1, 2, 3. So we have different resistances. Let's check the voltage here at each resistor. That's 8.9 at the first one, 8.99 at the second one, and 8.99 at the third one. And we know, of course, that the total voltage of the battery, since it's set at 9 volts, is going to be 9 volts. So that's the voltage. Pretty much the same everywhere, a little bit less, 8.9, 8.9, 8.9, but the same at all of the 3 resistors. Let's check the current. So 0.3 there, 0.15 there, and 0.6 there. I'll do that again. So 0.33 amps, 0.15 amps, and 0.6 amps. And it's 0.33 amps is the total. So now we've got enough information to fill out our last table. Oops, we forgot to fill out the total amps as it's shown in our circuit. So I'm measuring the total current right here in the circuit as it's shown on the diagram for part 9. So you should have all the information you need for table 8. You can calculate the total resistance by dividing the total voltage, which we took a reading here, by the total current, which we took a reading here. Now let's look at the questions. How is the total resistance related to the individual resistances? Explain what you think is happening. So make that calculation for that third column at the bottom and explain what you think is happening. Then you can look up the mathematical relationship for finding the total resistance in a parallel circuit. If you go to this website, you can scroll down to the number 4 and it will show you the relationship. Show at least in one way that your data fits the equation. So find the equation on this website and set up your data in that equation and show me that that equation is indeed true for the circuit that we just looked at. 39, you get to do a little bit of storytelling. Imagine you and your friends are running around in your neighborhood like electrons in a circuit. Make up stories that would serve as good analogies for explaining the difference between parallel versus series circuits. You can think about explaining parallel versus series circuits to maybe a younger sibling or a cousin or someone in terms of friends running around a neighborhood. Summarize the similarities and differences between series and parallel circuits and include your reasoning about what you think is happening in those series and parallel circuits. Thanks so much for doing this lab. I look forward to doing the next lab with you. Thanks so much. Bye-bye. Don't forget to put your lab sheet in the Dropbox.